OMP source preference. In this lesson, we are going to explore a typical misunderstanding of the OMP Best Path Selection process in scenarios with multiple vSmart controllers. Along the way, we are going to talk about the order of operation between the OMP send path limit parameter and the OMP best path algorithm. The initial state. We are going to use a topology consisting of 6 vEdge cloud routers vEdges 1 through 6 and to vSmart controllers vSmart 1 and vSmart 2. By default, when multiple vSmart controllers oversee the overlay fabric, vEdges establish an OMP peering session with 2 of them. This is controlled by a system parameter called max OMP session set to 2 by default. For the purpose of this demonstration, the max OMP sessions parameter on each vEdge is set to 1, which means that each vEdge will only form an OMP peering session with one vSmart controller. As illustrated in figure, vEdges 1, 2, and 5 have established an OMP session only with vSmart 1 1.1, 1.30 and vEdges 34 and 6 only with vSmart 2 1.1, 1.40, respectively. We can verify this directly on the vSmart controllers. You can see that vSmart 1 has OMP peering to vSmart 2 and to vEdges 1, 2 and 5, and vSmart 2 has OMP peering to vSmart 1 and vEdges 34 and 6. There are 2 WAN transports that are not illustrated in the topology, an Internet cloud and an MPLS cloud. Each vEdge has to transport attachments 1 tloc marked with the BIS Internet color and an IP address from the range 39.3.0.0, 16 highlighted in orange and 1 TLOC marked with the MTLS color and an IP address from the range 10.10.0.0, 16 highlighted in green. 5 edges 123, and 4 are directly connected to subnet 10.1, 1.0, 24. In VPN 100 and advertise the subnet to their respective controllers. You can see that vEdges 1 and 2 are advertising to 10.1.1.0, 20 for subnet to vSmart 1 1.1.1.30, and vEdges 3 and 4 are advertising the 10.1, 1.0, 20 for subnet to vSmart to 1.1.1.40. The question. Knowing that all routes to 10.1, 1.0, 20 for VPN 1.0 have identical values for a D250, OMP preference 0, tloc preference 0, origin type connected, and origin metric 1. There is no policy applied on vSmart. That everything else is by default. Could you guess which OMP routes to subnet 10.1, 1.0, 20 for will vSmart 1 choose as best? What about vSmart 2? Which OMP routes to subnet 10.1, 1.0, 20 for will vEdge 5 install in its VPN 100 routing table? Which OMP routes to subnet 10.1, 1.0, 20 for will vEdge 6 install in its VPN 100 routing table? The common misunderstanding. In Cisco SD-WAN, vSmart controllers establish a full mesh of OMP peering sessions between themselves and distribute all OMP routes they learn to all other controllers. Therefore, in our topology, both controllers will exchange all OMP routes, resulting in both knowing all paths to 10.1, 1.0, 24 in VPN 1.0. However, the key point here is in what order will each vSmart controller sort the OMP routes. We have already said that all OMP routes to 10.1, 1.0, 24 have identical values for AD250, OMP preference 0, tloc preference 0, origin type connected, and origin metric 1. Therefore, all 8 routes will be considered equal cost on both vSmarts. However, using the T-breakers on each controller will yield a different result. From the perspective of vSmart1, the controller receives for OMP routes to 10.1, 1.0, 24 from the direct OMP peering with vEdges 1 and 2. At the same time, the controller receives another for OMP routes to the same destination from vSmart to the routes that vEdges 3 and 4 advertise to vSmart 2. Therefore, according to the first T-breaker of the OMP best path algorithm, vSmart 1 will prefer the routes coming directly from vEdges 1 and 2 over the ones coming from vSmart 2. From the perspective of vSmart 2, the controller receives for OMP routes to 10.1, 1.0, 24 from the direct OMP peering with vEdges 3 and 4. At the same time, vSmart to recedes another for OMP routes to the same destination from vSmart when the routes that vEdges 1 and 2 advertise to vSmart 1. According to the first T-breaker of the OMP Best Path algorithm, vSmart will insert the routes via vEdges 3 and 4 at the top, and then the ones via vEdges 1 and 2 that it received from vSmart 1. In the end, both controllers will know about all 8 paths to 10.1, 1.0, 24, but each vSmart controller will insert the routes in its VPN 100 route table in a different order, as illustrated in figure. Well, let's now see how the fact that each vSmart controller sorts the routes in a different order affects routers vEdge 5 and 6, because the OMP send path limit parameter is set to 4 by default. Each vSmart controller will only advertise the first for equal cost best routes to its OMP peers. In our example, this means that vSmart 1 advertises only the routes via vEdges 1 and 2 to vEdge 5 5.5, 5.5 as you can see in the output, and vSmart 2 advertises only the routes via vEdges 3 and 4 to vEdge 6 6.6, 6.6 as you can see in the output. In the end, router 5 won't know that subnet 10.1, 1.0, 24 is reachable via vEdges 3 and 4 at all, and router 6 won't know that the subnet is reachable via vEdges 1 and 2. Let's verify this by checking the routing tables of both routers. You can see that vEdge 5 has installed the routes via vEdges 1 and 2, and that vEdge 6 has installed the routes via vEdges 3 and 4. Of course, we must have in mind that the maximum number of equal cost routes that a WAN-edge router would install in its routing table is controlled by the OMP CCNP limit parameter. The key takeaways. In this lesson, we have seen how the first tiebreaker in the OMP Best Path algorithm works and how it interacts with the OMP send path limit parameter. The question is, what does all that mean for a real-world deployment? The default value set by Cisco for every parameter is not random. They know that 99% of the network environments would have to vSmart controllers per region and for equal cost routes per destination, because the typical branch network is dual-homed, dual transport. However, in a network region with more than 2 vSmart controllers, vEdges may use suboptimal paths to destinations if either one of the following design recommendations is not met. Each vEdge has an OMP peering session with every vSmart controller in the region. The number of OMP sessions that a vEdge router could have is controlled by a global system parameter called maxOMP sessions, set to 2 by default. The OMP send path limit and the OMP CCNP limit parameters are set according to the maximum number of equal cost paths that exist in the region. Both values are 4 by default.